Okay, now, something you should have been pondering, and it's relevant to how we change a variable in a Bernoulli equation, or in general, how we do a change of variable in a differential equation. And this is your first real contact with the idea of changing a variable in an equation like this. Now, you change variables when you do integration by substitution, okay? So the idea of a change of variable, we're generalizing a little more, we're seeing it in a little different context, but it's kind of equivalent. Okay, so let's just think, okay, so let's say that y of t equals t to the 3/2, okay? Now, if we have the expression, let's say, cosine ty of t, and we want to take its derivative, okay? Well, it's this, right? Okay? And of course you can get this, you get negative sine of t, y of t. And you just write that as cosine of t y prime. Okay? Y has the derivative. Okay? Now, if you have the expression v, well, let's just take this one. Okay, let's take the expression y of t raised to the 4th power. Okay? Now, if you say that the derivative of this is 4y of t, 4y of t to the 3rd, so that the this expression, you'd want to say has this derivative, right? And that's not quite right. Okay, and you can check out and see why it is. Y of t to the 4th power is t to the 6th, right? Is that equal to 4 times t to the 3/2 cubed? Well, this is 5t to the 5th, and this is 4, not 5, okay, times t to the 9/2. Clearly not the same. So what's wrong with that? We're taking a derivative of 4th power, we're getting 4 times the 3rd power, right? Well, it's because y is a function of t. It's 4t to the 9/2 times the derivative of t to the 3/2. Which still is going to come out with a 5 there, which is kind of weird. Anyhow, let's see, I probably did something kind of dumb, but see how this is going to work out. Well, derivative of t to the 3/2 is 3/2 t to the 1/2. T to the 1/2 times t to the 9/2 is t to the 5th, right? And 3/2 of 4 is 6. And see, I told you I'd done something bigger. That's obvious, right? Once I saw it was going to be a 5th power, I just wrote down a 5 there without thinking. What do you mean? Okay, but okay, now this does come out then. 3/2 of 4 is 6. T to the 1/2 times, okay? So what I'm saying here then is that y to the 4th prime is not equal to 4y to the 3rd when the prime is derivative with respect to t. Y to the 4th prime equals 4y cubed, that's fine, y prime, by the chain rule. okay? And you could also say that y to the fourth, okay, y is the inner function of this derivative, okay? Okay, it's like this is your analogous to your g prime of t times f prime of g of t, where g is your I'll write the t dependence. G of t equals your y of t, and f of t, or f of whatever, f of x equals x to the fourth. So f of g of t is your f of y of t, which is the fourth power of your y of t in this. So that relates it, and hopefully, you know, that this is something, really, people tend to not understand why that y prime comes up when you do implicit differentiation. And that's something you should review and get straight. Okay? It's a chain rule. Okay, well, anyhow, so that's what we get. Now, what's that relevant to? So what we really want to talk about is change a variable in a Bernoulli equation. Okay? Now, the Bernoulli equation, and we talked about it last time, and it was a homework problem where I told you what the change variable was and asked you to see how far you could go so I don't have to do quite as much explanation in deriving this thing, so I can concentrate on the algebra mistake I always make when I do this. Really stupid, I do it all the time. So I got to be careful. I don't remember exactly what it is. I know kind of where it happens. Now all I got to do is pay attention and not confuse my laws of exponents. Something I nag my pre-calculus students to get straight. Okay? But there's a place where it always, I certainly know the laws of exponents. This thing always, there's something I always write down that's wrong. Okay, so even basic fundamental laws that you learn in pre-algebra can still confound you, even though my algebra's always been pretty good. I mean, all the way through in higher levels. Okay, my ability to manipulate stuff. And this was happening to me even before age started to deteriorate my skills. Okay, so there's something loose in my brain. There's some kind of DNA fragment that causes it. Okay, the DNA made me do it. Okay, well, whatever. Okay, so I'm just giving you a little context. You got to be careful with your algebra when you do this. Okay, so your Bernoulli equation is y prime plus p of t y equals q of t times t to the n, which is it's linear over here, and it is a linear equation, okay? Because you just have a y prime and a y. You don't have any y to the 3 halves or any weird stuff on y. And actually you do, because it's y to the n, not t to the n. Over on this side, though, it's linear. But because of the y to the n, it's not linear. Okay? We convert this to a linear equation using v equals y to the n. There's our whole premise. Okay? And part of the premise is we're going to figure out m to make the equation linear in V. Okay? Now, when I first saw this, I think it was kind of a revelation. I didn't pursue a field that would cause me to have to do a lot of bizarre changes of variables. Not that I wanted to avoid it, although, you know, when you first see it, you kind of want to avoid it. So I never got real good at figuring out how these things occur to people. Okay? But in this case, you can kind of trace Bernoulli's thinking. Okay? When he saw this, it actually turns out to be a fairly obvious change of variable, but he did it before people were doing a lot of changes of variables, I think. I don't know that much about the history of how ideas evolved in the 17th century. Okay? But I kind of suspected, so I've always liked speculating about, you know, that never got any deep insights on it, but it's still fun to speculate. Okay, so anyhow, okay, you got V equals y to the m. Well, you got a y prime, okay? Well, you're going to want to have a V prime, and of course that's then m y to the m minus 1, and that's all you write down if you forget this. But y is a function of t, and your variables are implicitly, you know, it's just implicit in the way the thing is stated. T is your variable of integration. Okay? So y is a function of t, y is your inner function, your outer function is the m power. Okay? And there's the inner function, the derivative of the inner function that comes out of the chain rule. Since that's what you started out by asking about. Yeah. When I took calculus, did implicit differentiation for the first week, I just dutifully wrote down that y prime, wondered where the heck it came from. Okay? I did figure it out. But I wasn't one of the geniuses that saw it immediately. Okay? I was one of the smarter guys that figured it out and didn't just do it. Okay? Let the geniuses go be geniuses. Okay. Okay, so you got that. And there weren't many of them, but you know, there were some. Okay, so you got this. So the other thing is, okay, now you've got a y prime here. So you're going to want to substitute something for y prime, right? Well, you solve this for y prime, which is real hard to do if you forget the y prime. Okay, so you got y prime equals, I just want to decide how to write it. Okay, I'm going to write it as v prime over m y to the m minus 1. Okay? But I'm also going to put that in a little just being really careful about my laws of exponents, because I think the thing that always glitches me is something like this. You know, wanting to write this as 1 over 1 minus m or something like that, even though I perfectly well know better. Okay? So I might want to put it in this form. I've got these two forms, whatever turns out to be more convenient. Of course, I'm not going to want a y in my equation, so I can't just replace y prime by this expression. But I can express y to the 1 minus m in terms of v because of this, right? So I can also say that y equals v to the 1 over m. Okay? I'll use this form for right now. Okay? Times v to the 1 over m raised to the 1 minus m times v prime. Okay? And of course, that's 1 over m What's v to the 1 over m to the 1 minus m?
Sorry, what?
This.
What is that? Okay.
How does that simplify? It simplifies laws of exponents. What's the power of a power? What do you do with the exponents?
You add them? Wait, let's look at that.
No, that's what you do if you have like a to the b times a to the c. You would add your exponents, and you have to know why. Go back and, in pre-algebra they explain why. Everybody forgets because you're allowed to go forward without understanding why anything works. And you do that because half your class is either too sorry or just doesn't quite have the DNA that'll connect it, okay? And we'll never understand for one of those reasons or some combination thereof. So you try to teach algebra to a class that can't really understand algebra. Half of whom can't really understand algebra, so they let everybody else not understand it, which is ridiculous. Let those people make their C's if they're doing their work, okay? If that's what it comes down to. Although giving somebody C's tantamount to shooting them in the head, with a rubber bullet, we don't hurt anybody seriously. Probably a bad analogy to use right now, but you understand what I mean, okay? Okay, well, digression aside, you need to understand why the laws of exponents work. Go back and review your pre-algebra. Get the OpenStax pre-algebra text and look up laws of exponents. If you don't find it there, look at their algebra. Okay, their elementary algebra, not their algebra 2. You have to understand that. Otherwise, you're going to screw up laws of exponents. Now, I understand that. I understood that from the beginning when I first saw it. And a lot of people did. You don't have to be a genius to understand it, but I actually was focused on understanding, not just manipulation, whenever, I had good teachers. And a more rigorous curriculum than people are getting right now. My point is that understanding I've used again and again. I always check out when I do this, except of course when I'm deriving this solution to the Bernoulli equation, and then I don't check it out and I screw it up. Okay? Okay, so just a big plug for laws of exponents. That was a long digression. Forgive me. Okay, we have this, right? You multiply the stupid exponents. Okay? Not because of a law that was handed down on a stone tablet, because that's what makes sense.
Okay.
A squared to the third power is a squared times a squared times a squared, which is a to the sixth. Because you got 6 A's if you write it out. It's not hard to understand. And that's the way it's always introduced. Even in the insane curriculum we have today. It's explained, but nobody's held accountable for it. Okay? So everybody goes through their algebra without doing it right. And doing it by memorizing a law rather than an obvious example. Okay, so you have V, now watch me multiply it wrong, to the 1 over m times V prime. Okay? And it's going to be handy. So it's always handy to write things out in a couple of different forms so that when you start using it, you have a vocabulary of forms that you can use when you're solving, when you're doing the manipulations. There's some forms that look better and act better than others. Okay? So you always want to know what different forms you have. We might want to write that as 1 over m minus 1. Right? Distributive law, divide the m into 1, you get 1 over m minus m over m, which is minus 1. Okay? I don't remember which of these forms works best, but I know that you always want to have a convenient form. And you probably don't want this form, but you still might when you get into the adventure that awaits you, okay, that befalls you. Okay, I guess adventures can befall you as well as await you. Okay, so here we have it. Now, well, now we have everything we need, because we can plug in v to the 1 over m where we've got y, and we can plug in one of these forms for y prime, and of course y to the n is just y to the 1 over m to the n, okay? Okay, so our equation becomes, yeah, I'll write it here and then I'll go to another board. Y prime is 1 over m v to the 1 over m minus 1. I'll use the last form. I'm not sure that's what I'm going to want, because I haven't worked this out in advance. I always want to have the spontaneity and the joy of discovery every time I do this. Okay, and then times v prime, right? So now we have something times v prime. Of course, we got this v in here, and that's going to be inconvenient until we figure out in the end that we want m to be 1 minus m. Now that's something I just kind of remembered. I wasn't sure about it, okay? But I'm pretty sure about it. Okay. Okay, then we have plus, what, p of t multiplied by y, which is v to the 1 over m, remember? Okay? And this equals q. I'm not going to write the t just to give myself enough room for the first time in my life. Okay, you got y to the n, and y to the n is v to the 1 over m. To the n, okay? So we have 1 over m v prime plus p of t v to the 1 over m equals q v to the n over m. So are we happy yet?
Sure not.
Yeah, probably not. Okay? And I won't be happy till I know I haven't screwed something up. And now, yeah, it's v to the 1 over m minus 1, because I was looking at that. Okay? Okay, well, let's write that down, because I've been fairly careful. And I'm fairly optimistic in giving myself a, 70% chance of not having screwed something up. But I always have to remain skeptical. From long experience, I know I need to be skeptical of what I'm doing. So we have v to the 1 over m minus 1, v prime, writing it out carefully, trying not to make a clerical error, p of t, v to the 1 over m equals q v to the n over m. Okay? Well, we want to put this in the form of a linear equation where we've got just v prime out in front. So what I'm going to do is I'm going to multiply both sides by m times the reciprocal of this. And now that I'm going to do the reciprocal, I really probably want to go back and write this as v to the 1 minus m over m. Okay? Just so I can be really careful in taking my reciprocal. I just want a rational expression up here for my power, so I can just do what I should do. Okay? So I'm going to change this to the 1 minus m over m form. Okay? Don't really have to do that, because when I take the reciprocal, I'm not going to take the reciprocal of this power, right? So maybe I would have been better off leaving it in the other form, and maybe it doesn't make much difference, okay? But a rational exponent's easy to look at, but it can mislead you, and I think that's the mistake I tend to make, just carelessly do the wrong power, okay? So I'm going to write this out carefully. So I'm going to write mv to the negative 1 minus m over m. Multiplied by 1 over m v to the 1 minus m over m v prime. That's my multiplying this by my first term, right? Of course, I'm going to have to multiply it by every term, so we're going to multiply it by the second term. I get this. And that's all the equation spread out over 3 lines. But you can see each term individually and make sure that I've written this down correctly each time. And then I want to actually do the multiplication. So what I get is, well, m times 1 over m gives me 1, right? And now I'm multiplying powers of v, so I add the exponents. Well, this exponent is the negative of this exponent, just because of the way I wrote it down. So it's clear that this gives me v prime. Okay? Then v to this power times v to the 1 over m. Okay? To the what? Okay, I add exponents, right? I get this. And that is going to equal m q v to the n over m minus the quantity 1 minus m over m. And now I regret having written this thing like this. Should have left it the way it was. But sometimes you take a wrong turn. And I didn't think it through. I just said, okay, I'm going to write it like this. We'll see what happens, okay? But look, if I'd have looked a little further forward, and I could have, you know, in my head, I could have seen what was going to happen. Maybe, if I was paying attention and not confusing things. Okay? What I see is that if I have this in the form 1 over m minus 1, I get v to the 1, right? Because I have a 1 over m minus a 1 over m, and then a plus 1. Okay? So I'll just write down a little note here that okay? And you can worry about how I get from here to here. Do you want to think about it? That's fairly easy to see. Okay? And you probably already do. Okay, so I've got v prime plus m p of t v. And look, this side's now linear. Okay? Now what about the other side? Well, that's m q v to what power? Well, it's n over m minus quantity 1 minus m over m. You have, and my m isn't real clear there. Try to make it clear to probably make it grotesque. Okay, but I have a common denominator, so I just add numerators. And that's going to be v to the n minus the quantity, well, I don't want to write it in that form, m minus 1 plus m over m. Okay? Well, remember, my goal was to figure out what m has to do to make this linear. Well, if I want to make this linear, then what can't I have on this side? This is now linear. Want to make this linear. What do we have to do to make this linear?
The power of v can't be any more than 1.
The power of v
Can't be any higher than 1.
can't be higher than what?
1.
It can't even be 1.
Oh, does that have to be 0?
Yeah, good.
Okay.
That's good insight. You almost had it, and you
Almost.
saw it immediately when I prompted you. Wonderful. That was very good. Okay? Yeah, if this power is 0, then boom, we have a linear equation, right? Right-hand side's linear if no v. Which happens if this equals v to the 0 equals 1. So, n minus 1 plus m equals 0. So m equals what?
N equals 0, right?
N plus 1.
What?
Yeah.
N plus 1?
No, if m is n plus 1, we get 2n over here.
Negative N plus 1. Sorry.
No, then we get negative 2. Solve the equation. What do you do to solve this equation for m?
Yeah.
What are you going to do then?
Yeah, subtract it from 0.
Subtract it from both sides. Yes, you're going to subtract it from 0. We're going to subtract it from both sides, because if you just subtract it from 0, it's still going to be here on this side, right? You know that, but you know you want to try to say things very precisely and very clearly. And what you just said was
Negative N.
an incomplete thought about